Lesson 7, how can I compare functions represented in different ways? So we're going to start by comparing an equation and a table. These steps give you all of the steps to determine what slope is and what y-intercept is. I'm going to look over here first to find what they want. They want to know which function has the greater rate of change. So I just need to know what the rates of change are for the two functions, and then I can determine which one is greater. So the first function, y equals 2x minus 3, I know that 2 is my rate of change. I need to find the rate of change for this table, and then I can compare them. So I'm going to label these x1, y1, x2, y2, and I'm going to use the slope formula to find the slope. So I'm going to substitute y2 and y1, so 0 and -3, x2 and x1, 1 and 0. Okay, so I know that this becomes a big old plus. So I get 3, 1 minus 0 is 1. So my rate of change for function 2 is 3. So now I can answer this. Function blank has the greater rate of change. Well, 3 is greater than 2. So that means that function 2 has the greater rate of change. Okay, now we're going to compare a table and a graph. All of these steps are to determine slope and y-intercept depending on what they're asking. This too is asking about rate of change. So I'm going to label x1, y1, x2, y2, and find the rate of change for function 1. y2, y1, x2, x1. So that gives me 6 minus 3 is 3, and 4 minus 2 is 2. So the rate of change for function 1 is 3/2. Okay, now we're going to look at function 2. So I'm going to find 2 points. Do this point and this point. I know it's hard to see. Okay, so my rise is 2 and my run is 3. So rise over run for function 2, the slope is 2/3. This is asking which one has a slower rate of change. Slower, less. 2/3 is less. So that means that function 2 has a slower rate of change. Okay, graph and a description. Going to find the equations for both and then compare. So this again wants to know about rate of change. So to find the rate of change here, I'm going to find 2 points. So let's see, right here and right here. So let's see, I'm going to rise 2 and run 1. So rise over run. So the slope for function 1 is 2. Function 2, okay, a squirrel weighs 27 grams at birth and gains 3 grams each day. So our initial value is 27. Our rate of change is 3 grams each day. So M equals 3. All right, so 2 and 3 are our rates of change, and it wants to know the greater. 3 is greater. So function 2 again has the greater rate of change. Let's do some more practice. Page 14. Evans planted 2 money trees in his garden and recorded their growth. So function A, the growth of the first tree is shown by this function. B, measurements were taken of the second tree and were recorded in this table. So it wants to know which one is growing the fastest. So growing the fastest would be a rate of change. And which one was tallest when it was first planted? So that would be the initial value, which is B. So for the equation, M is the rate of change and 5 is the initial value. We have to find it for this now. So I'm going to do x1, y1, and x2, y2, and use my slope formula. So 12 and 9, 3 and 2. 12 minus 9 is 3, 3 minus 2 is 1. So the rate of change for this table is 3. To find our y-intercept or our initial value, we look for where x is 0. So that means that B is 3. Okay, so it asks which of the trees is growing the fastest. So I'm going to compare 4 and 3. So 4 is greater than 3. So that means that function A has a greater rate of change. Which tree was the tallest when it was first planted? A was 5 feet tall and B was 3 feet tall. So function A had the tallest tree when it was planted. Okay, next one. Arabella and Kaya adopted puppies. They weigh their puppies weekly. So here we have a table for Arabella's puppy and Kaya a graph. They want to know whose puppy is growing the slowest. So this is our rate of change. And then whose puppy will weigh about 13 pounds in 7 weeks. Okay, so this has to do with rate of change. So I'm going to label x1, y1, x2, y2, and use my slope formula to find the rate of change. So substitute 5 and 3, 3 and 2. 5 minus 3 is 2, and 3 minus 2 is 1. So the slope is 2. Let's look over here. Okay, my graph, the intervals are 2. So let's see. My rise would be 2, and my run would be 2. So rise over run is 2 over 2, which is 1. So whose puppy is growing the slowest? Well, 2 and 1, 1 is less. So that means Kaya's puppy is growing the slowest. Whose puppy will weigh about 13 pounds in 7 weeks? Okay, well, if we look, let's take a look here first. This rate of change is 1. So if I continue my table to 7, let's see what would happen here. The rate of change is 2. So that means this would be 9, this would be 11, and this would be 13, which is what it asked for. So Arabella's puppy would weigh about 13 pounds in 7 weeks. Okay. Billy, Joe, Bob, and Sally Sue study weekly to improve their grades. Here's Billy Joe Bob's grade average in a graph and Sally Sue in a description. Whose average is improving the greatest? And what will Sally Sue's average be at 5 weeks? Okay, so we want to know about rate of change. So to go from here to here is a +5, and to go from here to here is a +1. So my rise over run is 5 over 1, which equals 5. So let's take a look at this description. So Sally Sue starts with a 70%. So that's her initial value, B, and makes an increase of 2% each week. So this is an increase of 2 each week. This is M. That's the rate of change. So whose average is improving the greatest? Well, 5 is greater than 2. So it's Billy Joe Bob. What will Sally Sue's average be at 5 weeks? Okay, well, let's write an equation. So Y equals the rate of change, or M, is 2. And it's an initial value of 70. So we're going to substitute a 5. Y equals 2 times 5 plus 70. So that means her average will be about 80% at 5 weeks.